Hi there, my name is Devin Hardy, and today we will be working on problem set 2, question number 12, part B. So in this question, they're asking us to solve for the freezing point of a solution given the freezing point depression constant of the solvent. So the question specifically asks, if carbon tetrachloride has a freezing point depression constant of Kf equals 29.9, what is the freezing point of a solution containing 100 milligrams of cinnamaldehyde dissolved in 1 gram of carbon tetrachloride, right? So let's start with what we know. So what's given is that we have 100 milligrams of cinnamaldehyde, which is C9H8O. So from this, we can get the moles. So we know that we have 100 milligrams of cinnamaldehyde, which is the same as 0.100 grams. So we have 0.100 grams of cinnamaldehyde, C9H8O, and then we can put that over the molar mass, which is here. I calculated that on the side. So we have 132.17 grams of cinnamaldehyde, C9H8O, over 1 mole of cinnamaldehyde, C9H8O, and then that will give us the moles of cinnamaldehyde. So when we do that, we get 7.57 times 10 to the negative 4 moles of the cinnamaldehyde, right? So that's the moles. Let's just circle that for now. We have moles. So then with the moles, we can then find molality. Molality is moles over kilograms. So we know we need molality because we're going to find the change in final temp. So we're going to find the change in final temperature, which is then ions times this depression constant times molality. So now that we have moles, we can put that over the 1 gram of carbon tetrachloride, and then we know that that's the same. 1 gram is the same as 1.00 times 10 to the negative 3rd kilograms. So we know we need moles over kilograms to get molality. So we can simply just put 7.57 times 10 to the negative 4 moles of C9H8O cinnamaldehyde over, or dissolved in 1.00 times 10 to the negative 3 kilograms of CCl4, carbon tetrachloride, sorry. So then now we have moles over kilograms, which will then give us 0.757 little m for molality, right? So now we have molality, okay? And then we know that I is 1. This is ions. I is going to equal 1, right? So we have I, Kf was given here, and then we have m now. So now all we have to do is plug in for change in temperature final. So we have delta Tf is going to equal I times Kf times molality, right? So then that gives us delta Tf equals 1 times 29.9 degrees Celsius times 0.757 molality. It's going to be 5 molality. So don't forget the units so that this would cross out, which gives us the change in final temperature, which would leave us in just degrees Celsius, which makes sense, right? So now we have that the change in final temperature would equal 22.6. So we know that that's a change in temperature. That's the reason it's negative. So then what we can do now that we have the change in final temperature, we're just going to take the freezing point of CCl4, which is that carbon tetrachloride. So if we have this freezing point, which you can just look that up, we have that freezing point, which is negative 22 0.9 degrees Celsius minus, because change in, minus 22.6 degrees Celsius would then give us the freezing point of the carbon tetrachloride would then be negative 45.5 degrees Celsius equals freezing point of CCl4. And that is your final answer.